Hi everyone, we're going to look at Pascal's triangle and look at the binomial theorem a little bit. First of all, Pascal's triangle starts with where you put a 1 at the beginning and 1 at two sides. Now on the sides here of the triangle, it's always going to be 1. And then what you do for the middle is you add 1 plus 1 is 2. And you put a 1 here, and then 1 plus 2 is 3, 2 plus 1 is 3, and then you put a 1 at the end again. So you put a 1 at the ends again, and then we're going to add 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then put a 1 at the end again, and you can keep going. We're going to do 1 plus 4 is 5, 4 plus 6 is 10, 10, 5, and we'll do one more. You get 1, 6, 15, 20, 15, 6, and 1. And so basically what you have is you can do 4, 6, I can make a little triangle here. 4 plus 6 is 10. And then we have another one here. We can do 4 plus 1 is 5. Or we could do this one, we could do 10 plus 10 is 20. So that's basically Pascal's triangle. And we can also use this to do our combination formulas, which we have over here. And basically what you do is you start with, you should know that NJ, so what we're using is n factorial over j factorial, times n minus, that's factorial, n minus j factorial. And so when you fill this out, we're going to always have, this is the second row, so this is going to be 2, 1. This side's going to be 3, 0. This side over here is going to be 3, 1. And in the middle here, this is going to be 2, 0, so this is going to be, this should be 2, 2, sorry. This will be 2, 2, this will be 3, 3. And what we have is this is going to be 2, 1, and then here we're going to have 3, 1, 3, 2, and then 3, 3. And then we do one more, we start with 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. And now in a previous video we talked about this formula. We know that if we're on this side, if we have n 0, this is going to equal, all of these are going to equal 1. And if you have n, this is all going to equal 1. Okay, so if I take 3, 3, this is 3 factorial over 0 factorial times, or 3 factorial times 0 factorial, which equals 1. And looking at Pascal's triangle, then that's what we have. This is just like we did on the previous slide here. You get the same numbers. Okay, and this is going to be helpful when we do the binomial theorem. Also, I rewrote the binomial Pascal's triangle here, and looking at the numbers here, this is where n is 0, n is 1, n is 2, n is 3. These right here is when n is j. On this side, it'd be when j is 1, 0, sorry. This side is j is 1, j is 2, example. So, knowing this, we know that anything to the 0 is 1, so that's what we get here. We also know that anything to the first power is itself, so that's a plus b. You also know this one. This one right here is a squared, when you expand it, plus 2ab plus b squared. Okay, so this is 1, and then that would be 1. So let's further do this one. And I'm going to use these 4 numbers, and I'm going to get a cubed, and if I want, I can put b to the 0 plus 3 a squared b to the first plus 3a to the first b squared plus 1 a to the 0 b cubed. Okay, so that leaves us a cubed plus 3a squared b plus 3ab squared plus b cubed, because anything to the 0 is just 1. Okay, and if you do the, let's do one more. Let's do the fourth. So I'm going to use these coefficients here to expand this. So it's going to be 1, a to the 4th, b 0, plus now I'm using 4, 4a cubed b 1 plus 6a squared b squared plus, back down to 4, a b cubed plus 1 a 0 b to the 4th. Okay, and that's just using Pascal's triangle. Okay, so what we want to do is look and see how many terms we have. On this b to the 4th, this one here, I have 1, 2, 3, 4, 5 terms. For b, to the 5th power, I have 6 terms. That's going to be important when we do expansions. And then, so if we had a plus b to the 6th, that would be 7 terms we'd be writing out. Another thing to note is that when you add these two, 4 plus 0, 3 plus 1, 2 plus 2, 1 plus 3, and 0 plus 4, they all equal the 4. And this one right here again was a plus b to the 4th. Okay? So that's how you would expand with simple things. And for the last thing, here's the formula that you use to expand. So it looks very complicated and all that, but we'll get into the next video where we actually expand the terms using our binomial theorem. All right? Thank you and have a nice day. Bye-bye.